Yeah, Joe Rogan, I really appreciate you inviting me to this podcast today. But I gotta get going. I got some math stuff to do. Hope you do great. Oh, jeez. Hey, what up there, pre-calculates? Mr. Stock Money here. Unit 5, Rational Functions, Day 2. Today we're going to talk about the short run behavior of rational functions. Again, rational just means that you have a fraction. Okay, and usually these are hyperbolic. So last unit when we talked about short run, we talked about the roots of where it hit the x-axis of a polynomial. But now we have two different things that we're going to really look for in the short run. So the first one we've encountered before is if we have a vertical asymptote. So in this one, it looks like x equals -1 is a vertical asymptote. So we're going to approach that infinitely, but we're never going to cross it, like it's going to creep up on it. But the second one that you haven't seen before is that there's going to be a hole in the graph. So right here we have a hole at x equals 1, and we're going to talk about how we find that y value. From Mr. Merritt's video, we talked about long run behavior, which you'll find the horizontal asymptote, and that's the limit as x approaches infinity, positive or negative infinity of the function. And in this case, our horizontal asymptote appears to be at y equals 0. Now, the horizontal asymptote can have some interesting things happen towards near the origin. So it can actually cross it and then reapproach it. So a horizontal asymptote can be crossed, but towards the infinities, it's approaching it infinitely. A vertical asymptote is never crossed. Okay, so to find the short run behavior, we're going to try and factor the numerator and denominator. So you can have as many different types of factors, number of factors as you can, okay? And then if we can simplify or cancel one out, whatever that x value is gives me the x coordinate of the whole, okay? And whatever's left over, if I plug x in to the what's left over part, that'll give me the y coordinate of the whole. If I can't factor it and cancel anything out, then I'm just going to set the denominator equal to 0. Okay, so whatever's in the top, we're going to set the bottom equal to 0. And then that's going to give me my vertical asymptote if there's any x values that make that happen. So just to review a little bit of the long run behavior, if I'm looking for a horizontal asymptote, again, that's n behavior. So this here, we're writing it out as the limit as x approaches positive or negative infinity. And there's three situations that can happen, okay? If we have a higher power x on the top than the bottom, some people call this top heavy, and you're either going to go to infinity or negative infinity, which means there's no horizontal asymptote. So if the highest was like x cubed at the top and there's an x squared on the bottom, there wouldn't be a horizontal asymptote. Secondly, if the higher power is on the bottom, we call this bottom heavy, and this will always equal 0. So your horizontal asymptote will be y equals 0, which is the x-axis. Finally, if we have the same power on the top and the bottom, that says same power, you can take the ratio of the coefficients. So whatever's in front of the same highest power on the top and bottom to give me my horizontal asymptote. So let's dive in. So this says find all asymptotes or hulls. All right. Step 1, we want to factor. Okay. So I look for GCF. I don't have one. It's a trinomial, so I want to add to 5 and multiply to 6, -6. Be careful with this one. We can't use -2 and -3 or +2 and +3 because it wouldn't multiply to a negative. So I would use +6 and -1. And then on the bottom, they don't have a GCF, but this would be an example of DOPS. So x plus 1, x minus 1. Didn't come out the way I wanted. All right. So if we can factor and cancel out the x minus 1, that means that we have a whole. If there was more that canceled out, we'd have more than one whole. And if I set x minus 1 equal to 0, there'd be a whole at x equals 1. What's left over now is x plus 6 over x plus 1. So the y value, if I put 1 in for x, so 1 plus 6 and 1 plus 1, gives me 7 over 2, or 3 halves, okay? So my whole would 3.5, my whole would be at 1 comma 3.5. Now, if nothing canceled out, or my next step is to set the denominator equal to 0. So I now would set x plus 1 equal to 0. So there'd be a vertical asymptote at x equals -1. Okay, because I subtract 1. And that's all of our short run behavior. The last thing that I would do is see if there's any horizontal asymptotes. So if I'm writing it out, I have to write the limit as x approaches positive or negative infinity of f of x. And we learned that we can compare the highest exponents either on the original or on the simplified version. Okay, and both of these would simplify down to 1, or like there's 1 over 1 as coefficients. So my horizontal asymptote be at y equals 1. So we have a whole at 1 comma 3.5, vertical asymptote at -1, x equals -1, horizontal asymptote at y equals +1. And I forgot to write that step down. Okay, moving on. Find all the asymptotes and or holes of the following. So first I want to factor again. So I got a GCF on the top, and I can do A and M on the bottom. Does anything factor out? Darn tootin'. So that means I have a whole at x equals 2, because x minus 2, if I set that equal to 0, would give me x equals 2. And my y value, what's left is x over x plus 8. So if I did 2 over 2 plus 8, that would give me 2/10 or 1/5 or 0.2. So my whole would be at 2 comma 0.2. Next, I check to see if there's any vertical asymptotes. So what's left is x over x plus 8. If I set that equal to 0, I would get x equals -8 by subtracting 8. And then finally, I would see, that's my short run behavior again. My long run behavior is the limit as x approaches positive or negative infinity. So again, I'm looking at the highest exponents on the top and bottom. If it's in standard form, they should be on the left, or I could use the highest exponents, x's with exponents on the simplified version. So this will simplify to either x squared over x squared, or x over x like the last one, which would simplify to 1. That's the coefficients. So my horizontal asymptote would be at y equals 1. So finishing this off, if they ask me to graph it, okay, we just found our short run and long run behavior for number 1. Okay, so you can look back to this slide. If I was you, I'd have this filled out, open notes. But if I want an intercept, I want to know where does it hit the x and the y axis. Okay, so if I have an x-intercept, like here, that means y equals 0. So I want to plug in y equals 0 to figure out what value of x is left over. If I had a y-intercept, say right there, the y-intercept is x equals 0. Like the y-axis, that's its equation, and the x-axis, y equals 0, is its equation. So if I plug 0 in for x, that'll solve for y. Okay, and then, I'd use my calculator in the table, second graph, and use as many points as possible. Okay, so if there's nice points, I want to make sure that I use those. So let's round it off. Graph, jeez. M of x, okay? So first I'm going to factor it. So top I can take out a 2x. Leaves me with x plus 3. Bottom is dops. So square roots, I can do x plus 3, x minus 3. Because I can cancel out the x plus 3's, that means I have a hole at x plus 3 equals 0, subtract 3, negative 3. What remains is 2x over x minus 3. So if I plug in negative 3 for x, 2 times negative 3 is negative 6. Negative 3 minus 3 is negative 6, which goes to 1. So I'm going to have a hole at negative 3, 1. And on the graph, just to overemphasize that there's a hole there, like an open dot, or you're going to have to point to it and tell me that there's a hole. All right. Next, is there a vertical asymptote? I would set the denominator equal to 0. Adding 3 over gives me x equals 3. We typically make this a dotted line, but I would label it so we know what's going on there. And then lastly, a horizontal asymptote is the limit as x approaches positive infinity is to the right, negative infinity is to the left. By inspection from the beginning, I know it's going to be 2 because it's got an even power on the top and the bottom. If I was doing it with a limit, the limit of the whole thing is comparing the highest power on the top and the highest power on the bottom. The x's would cancel out to 2. So I'm going to have a horizontal asymptote at y equals 2. Again, please label it. So this is the last part that's kind of new-ish. Maybe not. So if I want the x-intercept, the x-axis is really y equals 0. Okay, we had 2x over x minus 3. So 0 equals 2x over x minus 3. You have two choices. For a fraction to equal 0, the numerator has to equal 0. If you're like, put the 0 over 1, and when I cross multiply, 2x times 1 is 2x. 0 times anything is 0. When I divide by 2, I get x equals 0. So there's my x-intercept. Okay, and this is going to be a special one. You'll see in a second. My y-intercept is when x is 0. That's the y-axis. So y equals 2 times 0 over 0 minus 3. Where am I plugging that into? I'm plugging that into my simplified version or the original. And 2 times 0 is 0. 0 minus 3 is negative 3. Can I divide by 0? 0 by negative 3? Use your calculator. You get 0. Okay. So this is a special one that they're the same. They're both the origin. So, I could plug in either the original or this into my calculator to get my t-chart. Like if I put 1 into this, I'd get 2 over negative 2, which is negative 1. put 2 into it, I'd get 4 over -1, which is -4. Okay, you want to have as many points on here that are whole numbers as you can. Okay, be really careful never to cross the vertical asymptote. We'll have to zoom in and see some special examples to see if we cross the horizontal. I know up here we're going to have some kind of curve, so if I put 4 in, 2 times 4 is 8, 4 minus 1, or 4 minus 3 is 1, so I know this will be at 8. If I put 5 in, 2 times 5 is 10, 5 minus 2 is 2, 10 divided by 2 is 5. 6 would be 12 over 3, which is 4. 7's not going to give me a nice one. 8, 16 over 5. 9 would be 18 over 6. 10 would be 20 over 7. So I think we'll just, I'm drawing on my computer, so this isn't very smooth, but we want to have a couple points. Okay, so if I put this in my calculator, it's going to tell me undefined at 3 and -3, but because x plus 3 canceled out, there was a hole there, so there's really no value there. And then this didn't cancel out, that's my vertical asymptote. Okay, so these are our homework problems to try. Again, slide 2 is very helpful to find, your short run or long run behavior. And then 5 is helpful to help you find the intercepts. I hope you enjoyed this today, and have a great day. Stock Money out.